I'm Dr. Lutzmary, Associate Professor in the Department of Computer Science and Engineering. I'm going to take the topic desktop virtualization and network virtualization for the subject computing. First of all, you have to know what is virtualization. It's a broader term. It's a virtual memory, virtual storage, virtual network, etc. So we'll be focusing on platform virtualization. Virtualization basically allows one computer to do the job of multiple computers by sharing the resources of a single hardware across multiple environments. So non-virtualized system and virtualized system. See the difference. The non-virtualized system, the hardware, so between the hardware and the operating system, you can have the virtualization. After it makes it possible to run multiple virtual container on a single physical platform. So what are the requirements of this? The third generation computer mission state S will be EMP DAR. The instructions will be privileged instruction, control instruction, behavior sensitive instruction. Properties for a virtual machine monitor or hypervisor, it should have equivalence, resource control capability and efficiency. So the diagram shows what is a hypervisor, virtual machine monitor and the virtual machine. So the virtual machine monitor have the virtual machine. Above that will be having the hypervisor, it contains a hardware. So here in the right side of the diagram, right side of this schematic, will be having the block devices, network, physical memory. Above that you will be having all the virtualized one. Then above that, the top of that, you can have the domain 0 and the domain U. So the equivalence, resource control, efficiency that comes with all the virtual CPUs, virtual memory and virtual control scheduling. So privileged instruction, control sensitive instruction and behavior sensitive instructions are applicable to the physical memory, device, block devices and device network. So computing infrastructure, one machine to one OS. So one machine to one. So operating system to several applications. Applications can affect each other. So a big disadvantage is machine utilization is very slow. So as you all know, Red Hat is the open source. So it has 10% hardware utilization, x86 SUs 18%, 15%. The utilization is below 25%. So computing infrastructure, if you do the virtualization, the hardware utilization will be 70%. Each application runs its own operating system. Each operating system does not know it is sharing the underlying hardware with others. The privileged levels will be current privilege level, descriptor privilege level and requested privilege level. So protection ring is also shown in the diagram. So virtualization challenge, how to read the descriptor. So base address, segment address, this is as far as the microprocessor level. So these are the challenges loading. So useful to the application of how to protect it. Depends upon the privileged instruction or what type of non-privileged instruction. So the full virtualization will have the challenge. The emulation layer isolates the virtual memory from the host OS and from each other. The portability, by emulating a consistent set of system hardware, the VM has the ability to transparently move between hosts with dissimilar hardware without any problem. The drawbacks may be traditional, see the diagram, S86, you can have the ring 0 to ring 3. Between ring 0 and ring 3, you can have the guest OS. So para virtualization, the guest OS is modified at the kernel level at ring 1. The guest is fully aware of how to process privileged instruction. The guest OS uses a specialized API talk to the hypervisor and this way execute privileged instruction. Para virtualization, hardware assisted virtualization, the VM runs in a privileged ring, then 0 and a virtual ring 1 is created. So see the diagram, you can have the hardware, device drivers, specialized APIs are used in the hypervisor and device drivers, you can have various number of applications. Hardware assisted, you can have most privileged to least privileged, ring 0 to ring 1, 2, 3. As ring 0, it will interact directly with the kernel. So VMX root, least privilege to most privilege, the server utilization approaches. Hardware assisted, it allows to run unmodified OS. Legacy OS can be run without any problem. Unmodified OS doesn't know it is running in a virtualized environment. It cannot take advantage of Any virtualization future approaches to desktop virtualization. Desktop virtualizing compared to other type of para virtualization, full virtualization, and other virtualization types, this model enables you to emulate a workstation load rather than a server. So this allows the user to access the desktop remotely, since the workstation is essentially running in a data center server. Access to it can be both more secure and portable, extending the concepts of virtualization for desktop servers. Hosted virtualization, this is for IBM mainframe virtual machine monitor that uses hypervisor 1 bare metal hypervisor. Then operating system level virtualization will be done. Desktop virtualization, you can have the server side and the client side workspace virtualization. Then application virtualization, isolation and streaming. We will see one by one. Desktop virtualization, see here, so a VMM or hypervisor running on a physical desktop. So see the diagram. So examples include Microsoft Virtual PC, Parallels Desktop for Mac OS, VMware Fusion, Wine. Use cases emulating Windows games on the Mac system, testing the code inside the virtual machine. So underpinning client-side workspace virtualization. Desktop hypervisors and the VMM don't necessarily scale to meet the enterprise needs. Because most of the providers have server products as well. Server-side workspace virtualization, a workspace, desktop operating system with a custom configuration running inside a virtual machine hosted on a server. Examples VMware VDI. So use cases centrally managed desktop infrastructure, security enforced and lockdown. Users can the pool of virtual workspaces resides inside on the server. Remote users log on to them from any network device via remote desktop protocol RDP. So connection brokers arbitrate the pool of virtual workspaces residing on a central server. So biggest problem with server hosted workspace virtualization is that it's a bandwidth hog. Performance is constrained by the performance of your network. Client side workspace as with custom configuration running inside a virtual machine hosted on a desktop. Examples Kidero managed workstation, Scintillation vThere. A virtual workspace is served out to execute on the client device. It centralizes the management. Its biggest advantage is security and isolation. So it serves to the remote users, defense contractors, healthcare providers. So application isolation will be there. Its example is Thinstall Trigens. So it's a application packaged with its own virtual copies of the OS resources. It might otherwise need to change registries, files and libraries. It increases the footprint of the application package. Currently, the memory requirement also increases. Application streaming. Server hosted application to the desktop such that the desktop application can execute before the entire file downloaded from the server. Example AppStream, Microsoft SoftGrid. So this is a periodic table for each and every application. Level of virtualization and extracted from virtualization desktop. Endeavor, Thinstall, so all the products are with the typical use cases are shown. So next topic is, the subtopic is network virtualization. Network virtualization refers to abstracting network resources that were traditionally delivered in hardware to software. It can combine multiple physical network to one virtual software based network, or it can divide one physical network into separate independent virtual networks. It allows network administrator to move virtual machine across different domains without configuring the network. It creates the network overlay that can run separate virtual network layers on top of the same physical network fabric. It decouples network services from underlying hardware and allows virtual provisioning of the network. So it is possible to programmatically can create, provision and manage networks all in software. Physical network sources, switching, routing, firewalling, load balancing, VPN. So it require only IP protocol forwarding for the physical network. So network and security services in software are distributed to a virtual layer and attached to the individual workload such as virtual machine or container in accordance with networking and security policies. When a workload is moved to another host, network services and security policies move with it. And when new workload are created to scale an application, necessary policies are dynamically applied for the workload, providing policy consistency and network availability. So benefits, it helps organization achieve major advances in speed, agility and security by automating and simplifying many of the processes that go into the data center network and managing network and security in the cloud. Thank you.